scientific notation is just a way to express very large and very small numbers as powers of 10.
Perfect.
In scientific notation, your number is going to be greater than
Mm-hmm.
or equal to 1 and less than 10.
Okay.
And then with the appropriate exponent of 10 expressing it. Say you
Okay.
got the number 1,000. Okay. It's going to come off
Okay.
as 1 times 10 to the third. Okay. This number here will always be between 1 and 10.
Perfect.
Okay. You'll never have a decimal there. You never have any over that digit. And then this will express by what power. Okay. That's how scientific notation works. If we've got, let's get an example from the book here. Say we got 51,000. Okay. And you want to express that in scientific notation. We'll get into significant digits a little bit here too to help you how to do it, but it'd be 5.1 times 10 to the, and what you did, you moved the decimal 1, 2, 3, 4 places.
All right.
Okay? So you moved it 4 places. You made that number smaller, right? 51,000 is a lot larger than 5.1. So you made that number smaller. So you made that number smaller. You got to make the exponent bigger. So it increases by 4. So sine notation number is 5.1 times 10 to the 4. Okay. We have a number like 0.000037. Okay. That would be, you move the decimal 1, 2, 3, 4, 5 places. Maybe make it between 1 and 10. So that's 3.7, which is between 1 and 10, times 10 to the, and we said we did 1, 2, 3, 4, 1, 2, 3, 4, 5 places. And you made that number bigger, right? Because you made that to 3.7 instead of 0.000037. So you make that bigger, you make this one smaller, 10 to the minus 5.
Perfect.
Okay. And that's scientific notation in a nutshell.
Great.
What's that?
Oh no, I was just agreeing. I don't think my reception's the greatest right now. So.
Okay. We'll make it work. Oops.
Exactly.
All right. So let's clear that and let's do a couple examples in your book to show we have everything. So write the number in scientific notation 130 and then 3, 6, 9 zeros. Okay. So scientific notation, again, you make between 1 and 3. So 1.3 times 10 to the, and the decimal point's right here. So you move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. You make that number smaller to make this bigger. So it's positive.
All right.
10 to the 11. And write each, let's see if we can go back the other way here. Let's do a 0.005. Okay. So that would be 5 times 10 to the, and you moved it 1, 2, 3 places. You made 3 places. You made it bigger, so you make this one smaller to keep the number the same.
Good. All righty.
All right, perfect. Multiplying scientific notation. So once we're in scientific notation, most numbers are expressed in that. We can use it to multiply. Say we want to take 3.1. It's not 3.1. 3.1 times 10 to the 5th times, times 6.8 times 10 to the 4th. Okay. When you multiply by scientific notation, you multiply these 2 digits, and then you add the exponents together. When exponents are multiplied, you add.
Perfect.
So this would be, get my calculator, 3.1 times 6.8 So 3.1 times 6.8 comes out to 21.08 times 10 to the, and you add those together, 5 and 4 is 9. Okay. Now that answer is not a sign notation yet, so you got to move the decimal
Correct.
back that way. So 2.108 times 10 to the, and we move the decimal one place and made it smaller because 2.1 is smaller than 21. So you make the other one bigger
Correct.
by 1. Made that smaller by 1, made this bigger by 1. So 9 plus 1 is 10 to the 10th. And that'd be your
Perfect.
answer. Okay, all right. If you want to, let's clear that. Let's do 3.9 times 10 to the negative 4 times 6.2 times 10 to the third. Okay. Again, you multiply the digits, you multiply 3.9 times 6.2, that comes out to 24.18. And it's 10 to the, and minus 4 plus 3 is negative 1.
-1.
Okay. So this becomes 2.418. And you've moved this place, made a smaller one, made this bigger by 1. Made that
All
bigger one, it becomes 10 to the 0, right?
Correct.
10 to any number raised to the 0 power is just equal to 1.
1.
So it's
Alrighty.
2.418. Okay. Now, if you multiply, if you divide by numbers, let's do some division.
Okay.
3.8 times 10 to the negative 6 divided by, let's say 6.4 times 10 to the, let's say third.
Okay.
So you work these numbers the same way. And if with an exponent, if you bring this up, you change the sign. So whenever you bring it up, just change the sign.
Okay.
So it becomes 3.8 divided by 6.4. Comes out to 0.594, 0.594 times 10 to the, and then we got negative 6 and negative 3. So that's negative 9. Okay, because when you're dividing, you bring it up and change the sign.
Mhm.
Okay, so this
All
becomes 5.94 times 10 to the, and I made this number bigger, so make this one smaller. So 10 to the negative 10. Made that one
Perfect.
bigger by 1, made that one smaller by 1.
Perfect.
Making sense?
Absolutely.
Cool. All right. So that's got that. Yeah. We'll do metric units in a little bit here. Now we're
Okay.
going to talk about significant figures. Okay. Significant figures
All
is
right.
how accurate you measure a number.
Okay.
You can't make a number more accurate, okay, through mathematical manipulation. In other words, if
All right.
you're only measuring a
Correct.
certain degree, it'll only be accurate to that degree. You can't have a number, you can't say, 100 divided by 2 is 50.0000 and go on forever, It has to be how good your measurement is. And so the significant variance is as to what you can see plus one number that's a guess. So if you got like a graduated cylinder here with water in it, and we measure what's called the meniscus, which is the bottom line. And if this is 49 milliliters, this is 48 millimeters, we can say that's roughly 48.5. Maybe it's a little bit more than half, so maybe 2. That's just a guess. That's your significant area, how accurate you can get. You can't say that's 48.52379.4 milliliters. It's not
Exactly.
you're not that accurate. All right.
All
So with
right.
that in mind, certain numbers, so all our data is measured values. Measured values have to have a significant number of figures. Certain numbers
Okay.
don't have significant figures, like counting numbers. If you got 20 students in the class,
Mhm.
you've got 20 students in the class. There's no 20.37,
Correct.
it's 20 people. It's a straight
Correct.
number. So that's
Correct.
not a measured value. So that doesn't count with significant figures.
Okay.
Only measured data contributes to significant figures.
Okay. Perfect.
You need to carry that through in how you're doing your multiplication, division, adding, subtracting.
Okay.
Are we rounding numbers yet? Multiplying, dividing. All right, so we have different rules for multiplication and division. And we have
Okay.
different rules for adding and subtracting.
Perfect.
Multiplying, dividing. Okay, let's say we've got 3.28. And let's say we got 4.007. Okay, this number here would have 3 significant digits.
Okay.
This number here would have 4 significant digits. Okay? When we're counting significant
Okay.
digits, we count every integer except 0. If 0 is
Okay.
between 2 integers, we count the zeros because it's
Okay.
measured to that value. Zeros in front of the number, leading zeros, are not significant.
Okay.
This number here has 2 significant digits, the 3 and the 7.
Okay.
That's a 0. Okay, so leading zeros are not significant.
Okay.
Trailing zeros are not significant unless they're after a decimal point. So if you've got
Okay.
64.900, that has 5 significant digits. Because
Okay.
the zeros don't change the number, right?
Correct.
They don't change the value. The only reason they're there is because we know they're significant. We've measured to that point.
Okay.
So it's 64.900. So zeros are significant after a decimal point. Before a decimal point, say 64,000. Okay. This has 2 significant digits. The zeros are placeholders.
Okay.
You cannot round 64,000 to 64. If you do want to borrow some money from it.
Exactly.
Yeah. So you can't, those are placeholders. So they're
Okay.
not significant. Okay. So in multiply, let's see what else. We got that. We got leading zeros and zeros in between numbers. All right. So let's do a couple examples with significant figures, and then we'll go into multiplication and division with it. So if I had the number
Great.
1.010, how many significant figures?
We have 4.
4. Perfect. If I have 0.053790, how many significant digits?
See, we have, that would be 5.
5. Perfect. Okay. What other examples do we have? 634,000. How many significant digits?
We have 3 right there.
Perfect. You got it. All right.
Cool.
So now when we're doing multiplication and division, okay, we're going to use the number of significant digits to determine our answer. The
Okay.
number with the least number of significant figures or significant digits is going to determine the number of significant digits you can have in your answer. So if we're multiplying,
Oh, okay. Perfect.
yeah, say 3.2 times 8.396. Okay. The least
Okay.
number of significant figures, the number with the least number of significant figure is going to determine the number of significant digit in your answer. So if we
Okay,
have multiply
perfect.
those together, yeah. So if we have 3.2 times 8.396, that gives you the answer on the calculator of 26.8672. Okay. And we're going to do 2 significant digits. So we round this number off to this point right there. And when we
Okay.
round numbers, if this number is less than 5, this number stays the same. If this number is greater than 5 or
Correct.
equal to 5 exactly, this number rounds up. So this round up to 2 digit would round to
Okay.
27.
Perfect. Perfect.
So let's do some sign notation ones. Say we
All
had
right.
8.937 times 10 to the fourth times 2.81 times 10 to the fifth divided by 3.96 times 10 to the negative 7.
Okay.
Okay. So we'll do the math first. So you take this number,
Mm-hmm.
times this number, divided by this number.
Okay.
Easiest way to do problems like this. If the number's on top, you hit multiply. If the number's on the bottom, you hit divide. Doesn't matter
Perfect.
how many there are, you don't have to use parentheses. That's the easiest rule to do.
Perfect.
I like to keep things simple. You keep it
That's-
simple, you make less mistakes.
Absolutely.
So 8.937, well, 8,000, oh, clear. 8.937 times 2.81, because they're on top, divide, it's on the bottom,
Mhm.
3.96.
Okay.
Okay, and that comes out to 6.34165,909 times 10 to the, so this has got 10. I want to put it a little bit different place. Okay, so we'll have 10 to the fourth
Mm-hmm.
times 10 to the fifth, and we bring that up times 10 to the seventh. We bring that up, change the sign.
All right.
So 9 and 7 is 16.
16.
10 to 16. And we're good to how many significant digits?
We are good to 3 significant digits.
You got it. Perfect. So this rounds off to right here. This number is less than 5. So 6.34 times 10 to the 16th is your final answer.
Perfect.
You seem to get this pretty quick. Good. All right, let's do okay.
Okay.
So simple rule is that don't worry about when you're doing the numbers, just do your integers first, then
Okay.
worry about your powers of 10 after that, your exponents.
Perfect. Perfect.
So for the top, you have 28.76
Okay.
time, I hit plus, 28.76 times 8.319 divided by 7.25 divided by 6.23. Do not hit times, because a lot of students, most students will say 28.76 times 8.39 divided by 7.25 times 6.23. That would be the wrong answer. Okay. If the number's on top, hit multiply. If the number's on the bottom, just hit divide.
Perfect.
Okay, just keep it simple.
Exactly.
5.29, 704, 854 times 10 to the, and you got negative, we got negative 6. We've got negative 5. And we got positive 5, I'm sorry. Because you bring that up, change the sign.
Exactly.
And then we have negative 3.
Negative 3. All right.
So everything comes up. So we have 10 to the 6 plus 5 is negative 1. Negative 3 is negative 4.
Absolutely.
And we're only good to how many digits?
Let's see. Let me look at those original numbers. We are good to 3 significant digits.
You got it. So you go right here. So this number is greater than 5, right?
Correct.
So this rounds up. 9 rounds up to 10. So this becomes 5.30 because it's 29 rounded to 30 times 10 to the negative 4.
Perfect.
Making sense?
Absolutely.
This is the part that most students have the hardest part with right there,
Okay.
right? So let's do adding and subtracting. Right, so
Okay.
we've finished most of this stuff here. All right, so adding and subtracting is a different rule. Adding and
Okay.
subtracting, your answer is good to the least accurate number, not the total number of significant figures.
Okay.
It's good to the least accurate place. So if
Okay.
we got 10.83 and we're going to add 2.7, okay? We add at 3, 15, 13.53. We're all the
Okay.
least accurate number is one place past the decimal.
Okay.
So you're only good to one place past the decimal.
Perfect.
So adding and subtracting is the least accurate number, 13.5. Okay, if we're going to subtract,
Perfect.
say we had 8.93 minus 2.78 plus 10.5 minus 8.7. Okay. Just put that in your calculator, make it easy. Say we have 8.93 minus 2.78 plus 10.5 minus 8.7. And that comes out to 7.95.
Okay.
Calculator. So what would your answer be?
Let's see here. So we are only good
You're
until
good to how many places?
we are good to one place past the decimal point. And since that's a 5, we are going to get 8.0. Or do we just drop it, or do we also round that? We don't. Do we round that? So yeah, okay. So it would be
Wait. 7.95. You're only good to right here, right?
correct.
Okay, so that rounds to 8 point.
8.0.
Yep, because you're good to this significant
Correct.
digit.
Perfect.
You just handle most of the tough stuff in the beginning.
Okay, good.
Let's see where we're at with that. So digits multiply. Okay. Now, when you're using exact numbers, we talk about exact numbers like kids in a classroom or
Yes.
what else could be counting numbers, and that is an exact number. So if you've taken,
Okay.
so if we have 15.94, so we measure out every student gets 15.94 grams of magnesium sulfate, and there's 24 students in the class. How many grams do you have to measure out? So it's 15.94 times 20, right? 24 times.
Correct.
Okay. Even though, well, let's do the numbers here so we have numbers to talk with.
Okay.
15.94. Oh, I can't hit my numbers right. 15.94. There, gosh, I'm having a hard time. Okay, 15.94 times 24 comes out to 382. We need 382.56 grams measured out of magnesium sulfate.
Okay.
Now, this number does not count as to determine significant figures.
Because it's just a counting number.
Right. Because it's 24.0000 as far as you want to go.
Yeah.
It's an exact
exactly.
number. Like, you're not going to cut a student in half. We got 24 students. So
Absolutely.
this is a measured value. So measured values determine your significant digits. So here we have 4 significant digits. So our answer is only going to have 4 significant digits.
Okay.
So it comes out to this is greater than 5.
So we're going to need 382.6 grams.
Yep, you got it. Perfect. That's exactly how you do it. You did adding, subtracting, significant digits with multiple calculations. We did that. looks good. All right, let's do a word problem. Word problems are always fun, right?
Correct. There.
Okay, a toxicologist measures the concentration of an illegal drug. Okay, the Olympics are going on. It's a good
Okay.
example right now. She measures five times and attains the value in milligrams per liter. 12.1.
Okay.
We have 12.1 milligrams. We have 12.9. We have 11.5, 13.1, and 12.5. Those are the 5 measurements.
Okay.
Okay. Calculate the average concentration. So average concentration, we add them up and then divide by 5, right? Number of our
Correct.
samples. So we add those up, we end up with 12.1, whoops, wrong button. 12.1 plus 12.9 plus
Alrighty.
11.5 plus 13.1 plus 12.5 equals 62.1. Okay,
Alrighty.
is that the right significant figures?
Let's see here. Let me look at all these numbers. Yes, we're still at 3 significant figures.
Not 3 because we multiply. The least accurate number. One place.
Ah,
Everyone one place past the decimal. I mean, it did turn out right. 'Cause
yeah,
you one place past the
that's right. Yeah, you're absolutely
But-
correct. Well, of course you're correct, but I did catch that. Yes, one least accurate. Yes.
I can make mistakes too. But if we add it to greater than 100, you have 4 significant digits because you're good to one place past the decimal.
Correct. Okay.
Okay.
That's,
And it's-
you know what? That's a very important distinction to remember.
Yep. That is divided by 5. So 62.1 divided by 5 equals 12.42. How many significant digits?
Well, we have 3 and 3. So 12.4.
Yeah, because this is a counting number. That's
Correct.
exact. 5 isn't a
Correct.
measured value, right? It's the number of samples that we have.
Exactly.
So it's 3 significant digits, so it'd be 12.4 milligrams, and it's per liter.